On January 3rd, 2026, the night sky will offer something rare and beautiful. The first full moon of the year will rise larger and brighter than usual. This is the wolf moon, named centuries ago after the howls once heard during deep winter nights. But this time, it is also a supermoon. At first glance, it feels harmless. Just a bright moon marking the beginning of a new year. Something people photograph, admire, and move on from. But for engineers who manage coastlines, power grids, and satellites, this is not just a moon, it is a scheduled stress test, one where multiple natural forces peak at the same time. And history shows that when systems are already under pressure, even small pushes can matter. This is why scientists and infrastructure planners quietly mark this week as one to watch. A supermoon occurs when a full moon appears near its closest point to Earth, known as perigee. The moon's orbit is not a perfect circle. Sometimes it is farther away. Sometimes it passes closer. When a full moon happens during that close approach, it appears larger in the sky. But the real change is not what we see. It is what we feel. The moon's gravity pulls on Earth constantly, shaping the rise and fall of ocean tides every day. When the moon is closer, that pull becomes stronger. High tides rise higher, low tides fall lower. In many coastal regions, supermoon tides can push water levels past normal safety thresholds, even without storms or heavy rain. This difference matters more than most people realize. During a full moon, the sun, Earth, and moon align in a straight line. When this happens, the gravitational forces of the sun and the moon work together instead of against each other. This creates what are called spring tides, the strongest tides of the month. Now combine spring tides with a supermoon. The result is amplified tidal force. More water is pulled toward coastlines. The sea pushes farther inland. Drainage systems struggle. Low-lying infrastructure begins to feel the strain. This is not theory. It is physics, repeating itself on a predictable schedule. January adds another layer to the picture. In early January, Earth is near perihelion, the point in its orbit when it is closest to the sun. This happens every year, often without notice. When Earth is closer to the sun's gravitational influence is slightly stronger. On its own, this effect is subtle. But when combined with a supermoon and a full alignment, it becomes relevant. So on January 3rd, 2026, three forces overlap. The moon is closer to Earth. The moon is fully aligned with the sun. Earth is closer to the sun than average. Each factor increases gravitational stress. Together, they produce some of the strongest predictable tidal conditions of the year. Most discussions stop with tides, but that is only half the story. Around 2025 and 2026, the sun is near the peak of its 11-year solar cycle, a period known as solar maximum. During this phase, the sun produces more sunspots, more solar flares, and more bursts of charged particles. These particles travel through space and interact with Earth's magnetic field. Most of the time, Earth is well protected, but strong solar activity can still cause problems, especially for technology. Solar storms can disrupt satellites, interfere with GPS, and affect radio communications. More importantly, they can induce electrical currents in long conductors on Earth, such as power lines. These currents are invisible, but powerful enough to overload transformers and destabilize power grids. A solar storm does not need to be extreme to cause damage. What matters most is timing. In past incidents, even moderate geomagnetic storms caused localized outages simply because power systems were already operating near their limits. If a solar disturbance hits when infrastructure is under stress, the margin for error shrinks. Protective systems trigger sooner. Backup systems engage more often. Equipment heats up faster. During a supermoon week, coastal grids already face higher moisture, salt exposure, and flood risk. It is this overlap, not any single event, that planners worry about most. Modern cities rely on infrastructure that was not designed for constant environmental extremes. Many coastal substations sit only a few feet above sea level. Some were built decades ago, when high tide flooding was rare. Salt water is especially dangerous for electrical systems. It conducts electricity, corrodes metal, and damages insulation. Even minor flooding can force shutdowns that take days to repair. During supermoon tides, water reaches places it normally does not. Add strong winds, storm surge, or heavy rain, and the risk increases quickly. This is how routine astronomical events become infrastructure challenges. Engineers do not focus on single moments, they focus on windows. The days before and after a supermoon matter just as much as the night itself. Tides remain elevated, recovery time between cycles is shorter. If something fails, crews may already be stretched thin. If solar activity spikes during this window, the chance of cascading failures increases. This is why the period around January 3rd is sometimes described quietly as a danger week. Not because something will happen, but because if something does, the consequences are harder to control. History offers reminders. In 1989, a geomagnetic storm collapsed Quebec's power grid in less than 2 minutes. Millions lost electricity, not because of wind or rain, but because of solar-induced currents. More recently, coastal flooding has shut down power in cities around the world. Events once considered rare now happen more often. None of these incidents were caused by a single factor. They happened because systems were already under stress. The Wolf supermoon fits that same pattern. This is not a prediction of disaster. Nothing about the Wolf supermoon guarantees failure or collapse. What it offers instead is awareness. A reminder that space and daily life are deeply connected. The moon does not stop pulling on the oceans because cities exist. The sun does not reduce its activity to protect power lines. These forces have always been there. What has changed is us. As sea levels rise, small tidal differences matter more. As technology grows more interconnected, systems have less room for error. The Wolf supermoon of January 3rd, 2026, reminds us that even predictable events can carry risk when conditions align. That night, the moon will appear calm and beautiful. Most people will never think about tides, transformers, or solar cycles. But the sky will be telling a story about gravity, about energy, about how fragile systems can become when pushed from multiple directions at once. The moon will not threaten Earth, it will simply do what it has always done. The question is not what the moon will do, it is whether our systems are built to handle what they already face. If this video helped you see space differently, support the channel by liking the video so others can find it. Subscribe for more clear, grounded stories about how the universe quietly shapes life on Earth. And share this with someone who believes space has no effect on everyday systems. Because sometimes the most important warnings arrive without sound, glowing softly above us in the night sky.